Hello, my wonderful calculus students. So this is going to be looking at the rest of our notes on section 5.4, the natural exponent function. So we got through a good amount yesterday, or on Monday if you're listening to this a little bit later. But we're going to finish out the notes together. So what we're going to look at first is to find the relative extrema. Hopefully you remember at this point that this is from a while ago, but it is your derivative. Sorry, I'm making coffee in the background. Please excuse that. Of your original function. The thing you have to be careful of here is that you're using the product rule, so it's going to be first times the derivative of the second, which in this case is negative e to the negative x, okay, because you're just taking the derivative, which is e to the negative x times the derivative of the exponent, so that's times negative e to the negative x, plus the second times the derivative of the first. Okay, so that ends up being negative x e to the negative x plus e to the negative x, okay? And then you can solve that, set it equal to 0. I'm going to factor out e to the negative x because they have that in common. So you have negative x plus 1. You can see that. Set them both equal to 0. So e to the negative x equals 0. And then negative x plus 1 equals 0. Okay? You actually can't do this one, so this is no solution here because it's e being raised to some power gives you 0, which doesn't happen. And then this one would give you x equals 1. Okay, so that's one of your critical values. From there, then you can make your number line, show that it's increasing or decreasing, whatever you need to do from there. So we put our 1 on our number line. Remember, this is going into your derivative function. Okay, I'm going to do f prime of like 0 and f prime of 2. So if you plug in 0 to your derivative, you end up with a positive, looks like, because then you get, for the second part, it's basically like e to the 0, which is 1, and 1 plus 0 is positive 1. Then if you plug in 2, you get negative. So it's going to be positive and then negative, which means, remember, you're increasing from here to 1, and then you're decreasing on the other side, making 1 a maximum. Yep. So then you want to just figure out what the maximum is by plugging that 1 back in. So we have a maximum at 1 comma something. Think about where you're plugging that 1 back into. Yep, it's your original equation. So if I plug 1 into my original equation, I'm doing f of 1 equals 1 times e to the negative 1. That's like 1 over e, so you can just leave it like that if you want, or you can give the decimal answer. Alright, next up we got finding the equation of the tangent line to the graph at the given point. So remember, that process is find the derivative, plug in your x value to find the slope, and then you guys can use your point slope form. So I'm going to start with the derivative for you. I like this song. This is fun. Okay. So you're going to do the derivative first. You know, take like 30 seconds, see if you can figure out the derivative, and then pause the video, come back, and I'll have the derivative for you. Okay, so the derivative ends up being x e to the x plus e to the x minus e to the x. So remember, you have to do product rule for this first part. So if you didn't get it, it's remember first times the derivative of the second plus the second times the derivative of the first minus the derivative of e to the x, which is c to the x. Okay, so then from there you want to simplify it a little bit. So we're going to be able to cancel out the e to the x's, so you just get y prime equals x e to the x. Remember, you plug in your x value and find the slope, and then write the equation line. So see if you can figure out the next 2 steps for me, please. Pause the video, come back to it. Alright, so hopefully you got your slope was e, because you plug in 1 for all the x's. And then you have your x and your y values, so you just plug them in. Just point slope form is much easier, or you can simplify and put it into slope intercept form. All right, so next up, we got the equation of the tangent line to the graph at this one. This is a little bit more complicated, but I want to see if you can just pause the video, figure it out from there, and then I'll have a bunch of work and the answer when you return. All right, so hopefully you took the derivative, but what I want you to notice is you can always use log properties to help you to separate first, and then it's easier to take the derivative. If you took it from the beginning, you have to use product rule / chain. So this is a lot easier if you separate first. And then you end up with 1 over x plus 1 over y dy dx equals e to the x minus y. You had to use chain there because it's e to the x minus y times the derivative of that power. So you do 1 minus dy dx. So then if you subtract your, or distribute your e to the x value, it's going to be a lot easier to work with. So what I did is I did minus e to the x minus y dy dx. So I just distributed from above. That's dx. And then again, you want to get all the dy dx's to one side and all the other things to the other side. So I would add the e to the x minus y dy dx to both sides. I'm going to subtract the 1 minus x to both sides, so it ends up looking like this. Okay, so I just added this term to the other side. I'm subtracting 1 minus x, so it's going to equal e to the x minus y minus 1 over x. Okay, and then you can factor, divide things out. So I'm going to factor out that dy dx. So I get 1 over y plus e to the x minus y equals e to the x minus y minus 1 over x. And then you divide it to both sides. So you get dy over dx equals e to the x minus y minus 1 over x over 1 over y plus e to the x minus y. Gross. Okay, that's not fun to look at. However, this is very similar to your last quiz where you want to cancel a lot of things out. So if you multiply top and bottom by xy, it'll do that because look at, these are your common denominators, right? So instead, I'm going to get dy over dx equals, I need a little bit more room. I don't know why I became southern, I'm sorry. Okay, so you get e to the x minus y times xy. I'm just going to put that in front. Minus, if you distribute this here, the x's cancel, so you have just y. Over, distribute this here, the y's cancel, so you get x plus xy e to the x minus y. So that is your slope, but we want to plug in the point. So I'm going to plug in the 1. Right, so you get, and I'm going to plug in the other one. What's nice is both of them are 1, so that was convenient. So it's like 1 times e to the 1 minus 1, which is 0, minus 1 over 1 plus the same thing you got on the left-hand side of the numerator. So 1 times e to the 0. E to the 0 is 1, so you literally have 1 minus 1 over 1 plus 1. So you get 0 over anything gives you 0, so your slope is 0. Weird. So think about what a slope at 0 looks like. It basically means you have a horizontal line, which if you think about the equation for that, it's just y equals. So your equation, weirdly enough, is going to just be y equals whatever your y value is in the original coordinate, which is 1. Crazy. All right, keep going. All right, next up, we got second derivative. This actually is not going to be too crazy for you, so I'd like for you to try the next one, and then we'll do the following examples together. So try this out, pause the video, come back, see what you got, go. Okay, so hopefully you got your first derivative to look something like this. Notice that between the top and the bottom, I just wrote it with a negative exponent because then it'll be easier to take your second derivative. So then your g double prime of x is negative 1/4 x to the negative 3/2 plus, and then you have to do product rule again, sorry, and you end up with e to the x times negative x to the negative 2 plus x to the negative 1 e to the x plus the product of this one. So I'm gonna scoot over a little bit so you can see that. So the derivative of this, you have to do product rule again. Same thing with up here, so just be careful on those. So then you have 1/x times e to the x plus e to the x ln of x. So just remember first times the derivative of the second plus second times the derivative of the first. And then from there you just have to simplify a little bit. So you can actually see if anything will cancel, which you'll be able to combine a little bit. So you can kind of see that, like, let's see, these two are the same thing, okay? So you get two of them. So your final answer ends up being g double prime of x equals negative 1/4x to the 3/2. If you wrote it as a radical, that's fine as well. That's a 3/2, not a squiggle. Sorry, that's from here to here. Then you get minus e over x squared. Again, I'm just like simplifying a little. Plus 2 e to the x over x. So you can combine these two and get that. And then you have plus e to the x ln of x. Crazy looking, but it is the second derivative. Cool. All right. Next up, we got the integral. Yeah, but what's nice is that the derivative of e to the x is e to the x, so the integral of e to the x is e to the x plus c. Woo! Yes! Awesome! Okay, so one thing to be careful of, you have to use u if it's anything other than x in the numerator. All right, so what I recommend for this first question is making your u, actually I want you to find u first. What do you think u would be? Yeah, that's right. It is x squared, which makes du 2x dx. Haha, it shows up here, 2x dx. Woo, yeah. So we have the integral, I know I'm being weird, of e to the u, right, du. The integral of e to the u is just e to the u plus c, and then you pop that u back in. So it's e to the x squared plus c. Beauteous. Try the next two. Okay, hopefully you got 1/3 e to the 3x minus 5 plus c, and then negative 7/3 e to the negative 3x plus c. So just a reminder that the bottom one's probably a little tricky, but a reminder about if you have a u that's not in your answer, so like here, oh, why did that become a marker? I didn't mean that to. Okay, u equals, in this case, 3x minus 5, but your du is 3 dx. So like you have to get rid of that 3 by putting the 1/3 in front, and then you integrate, okay? The bottom one is a little harder because you have to use the u is negative 3x. So you get negative 3. So think about how you would get rid of that, but then you already have a 7 in front. So it's basically like you're doing negative 1/3 in front of your integral, but then you already have a 7, so it becomes negative 7/3. If you're not sure why that works, just let me know later. Okay, so we are going to be solving for you, aka taking the integral for these. I want to see if you can figure these out, the first two, and then again I'll show some work on those so it can help you out if you're not sure. But just be careful on your u for the next one, because that part's a little bit challenging, but think about what's in parentheses. That'll help you. So it's not necessarily your denominator here. That's my hint. And then same thing for the next one. It's whatever you think about being in parentheses. All right, so this next question, your u should have been 1/x, so your du has to be negative 1/x squared dx. Just remember that the you can rewrite this as x to the negative 1/2, or sorry, the negative 1 if that helps you, and then integrate by adding, take the derivative by subtracting 1 after you bring it in front. So it becomes negative 1 times x to the negative 2, which is negative 1 over x squared. That shows up here, but you need to factor out the negative that shows up there. So it's going to be e to the u, and then du again is 1 over x squared, but you have the negative. So again, it becomes negative e to the 1 over x plus c. The next one, I recommend u being cosine of x. So that means du is, that is correct, negative sine of x dx. So what do we need in front? It's a negative. So then we have e to the u du again. The integral of that is e to the u, but you have a negative plus c, so it's negative e to the cosine of x plus c. All right, next up, same thing, except now we plug in numbers. Woo, numbers. Okay, so we kind of did this question from above, but what I want you to notice is that now our u is going to be e to the x. Some of you may have already figured that out. So that means du, shocker, e to the x. Cool, dx. Again, shows up there, so we don't have to do anything with like a weird inverse product rule. So that means I have the integral from negative 1 to 0 of cosine of u, so be careful there, du, right, because that's e to the x. So the integral of cosine, yep, it's sine of u between negative 1 and 0. Plug your u back in. Sine of e to the x between negative 1 and 0. So plug 0 in, subtract the, after you plug in 1, so sine of e to the 0 minus sine of e to the negative 1 gives you a weird decimal of 0.43. Yeah, good job. All right, try the next one for me. All right, so hopefully you got 0.62. If you did not, there may have been a few issues. If you had trouble figuring out what u was, you might want to come see me, because that is something that we have to get before we move on to this stuff, and it was from some previous units. So your du was e to the x, hopefully. If you got this part and then you still got the wrong answer, it's probably because you put in the absolute value in your calculator, but you don't need to at this point because this is a positive already, so you can just do the ln of 1 plus e minus the ln of 2, because e to the 0 is 1, so this becomes 2. Okay, so 0.62 is the answer to that. We have a few more questions on the back side, so I'm going to have you scoot back to the back. See if you can set up the integral, and then I'll kind of work through it with you on this next question. All right, so hopefully you set up your integral correctly from, that's a 0. I don't know what shape that looks like, but from 0 to 5 of e to the negative x. So now you want to integrate it. If you need to use u substitution here, feel free, but I think some of us are kind of getting how to go from here. So you want to integrate, if you make u negative x, that means that du is negative 1. So that means I need a negative 1 here to cancel that out. So I'm just integrating e to the u du, which is just e to the u, but we're integrating between 0 and 5 still. So I get negative e to the u, which is negative x, between 0 and 5. So I'm going to do negative e to the negative 5th minus negative e to the 0, because you can't have a negative 0. So it becomes negative e to the negative 5th plus 1, okay, which ends up being 0.99. Okay. All right, last question. Woo, last question. Get excited. All right, So it says find the particular solution that satisfies the initial conditions. This problem is kind of cool because they give you the second derivative. So you have to think about what you have to do to that to be able to plug in the points that they gave you. So basically they're having you figure out the original function. So if they give you a point on your derivative, how do I get the first derivative if I'm given the second derivative? That's right, take your integral of sine of x plus e to the 2x. Then you'll have to take the integral of whatever you get to find the original function. Good. Okay, so take the integral of that. Pause it. Take the integral. Take it. All right, so you get this stuff. You get negative cosine x plus 1/2 e to the 2x plus c. If you didn't get that, the integral of sine of x is negative cosine. The integral of e to the 2x is 1/2 e to the 2x. If you make u 2x, if that helps you, that means that your derivative is 2, so you got to handle that 1/2 in front by getting rid of it. If you have no idea what I'm talking about, come and see me, because this process should be kind of second nature at this point. So that means we can now plug in this point. That means I can plug in 0 for x, 1/2 for y to figure out c, because I want to find the equation of the first derivative so I can find the original function. So if I plug in what I know, that means I have 1/2 equals negative cosine of 0 plus 1/2 e to the 0 plus c. This just gives you 1/2. This gives you negative 1, because if you think about it, the cosine of 0 is 1, so this just becomes negative 1 plus 1/2 plus c equals 1/2. So c equals 1. So your original derivative function is negative cosine of x plus 1/2 e to the 2x plus 1. So all I did was I plugged c back in. But now I have one more point they gave me. They gave me the original function point. So they gave me a coordinate in the original function at 0, 1/4. So what I can do now is find my original function. And how I do that, if I'm given my first derivative, that is correct. Take the integral again. So negative cosine of x plus 1/2 e to the 2x plus 1. Okay? Take the integral of that, pause the video, and then I'll have the answer. Okay, hopefully you got this. One way to check that you did it correctly, remember, is you can always take the derivative of things to go backwards just to verify that they work. So like the derivative of this is e to the 2x times 2 times 1/4, which simplifies to what you had. So that's a helpful hint. All right, now we're going to plug in the point to figure out c, so you can find the regular equation. So the other coordinate they gave us was 0, 1/4 for the function. So that means I have 1/4 equals negative sine of 0 plus 1/4 e to the 0 again plus 0 plus c. So 1/4 equals sine of 0 is 0. So this cancels. This gives you 1/4 plus c. Oh, c equals 0. Coolio. So then I just rewrite my function, which is all that jazz with the c plugged in, which is 0. So it's like gonna make it go away. So f of x equals negative sine of x plus 1/4 e to the 2x plus x. Okay, have an awesome rest of your day. Enjoy. Please come see me with questions. You can ask me lots of questions on Tuesday because we're going to be doing a little practice of everything we've done. All right, see you later.